All right, so we'll record this in case other people have questions. So we'll talk about the new class structure, see if you have any questions, and then we'll try to do, if you have any questions, if you've been reviewing. We do still have exam planned for tomorrow. We'll talk about what that will look like. So let me talk about the new course structure. I uploaded a new file in D2L. All right, so if we go to the home page, there is a new syllabus with kind of updated details on how the class is going to run. If you looked at this last night, I actually made a couple of additional changes. So the way we're going to do this is we are going to use my colleague, Dr. Sugar's videos for our lecture. There's like 5 of us teaching the same class right now. It doesn't make sense to have us all record videos for lecture. So we'll have her videos and her notes. They're in D2L right now. And you'll be expected to kind of watch those, take some notes, highlight any you have questions on. And then I changed it. I think I can only handle, just in terms of my schedule with my kids being home and other obligations, 2 of these a week. So we'll do 2 one-hour meetings a week during our regular time. And I'm going to do Tuesday, Thursday. And we'll meet like this. You can ask questions. We can go over the notes again. Like, hey, I was looking at Dr. Sugar's like page 42. Can we go over that again? I didn't understand that. You know, any questions you had like that, you can email me those ahead of time if you want. Whatever you want. You can ask homework questions. There are ways for me to set up a little breakout room. So if people are there kind of hanging out, working on stuff, I can go like to the side with a couple people like, hey, we're going to work on example 4. So there's some things that I'm going to try to figure out there, but those will be synchronous and those are optional. They'll be recorded, they'll posted. I'm not taking attendance. So we're not going to do anything like that. So these are all totally optional. Then for homework, just keep working on your homework list that you've got, and we'll have quizzes on those weekly or exams. So quizzes or exams every week. Let's see here. I'm going to do a little, where is my manage participants window? I'm going to mute everyone just so we don't get any background talking there. So feel free to unmute yourself if you have a question. So I just muted everyone so we don't get a lot of background noise. So the quizzes and exams, what we're going to do is I'll just post them to D2L and you can download it, do your own work on your own paper, and then just take pictures and upload in a PDF form to the Dropbox for that. We'll have a long window. I think I'm probably just going to post in the morning and then have you turn it in by the end of the day. And I just think people's schedules are too crazy for me to give like, oh, usually we had 25 minutes in class. So you have a 25-minute window where I'll post it and then you have to submit it. Like, that just seems crazy. So I think for quizzes and exams, like quizzes, I would post, we have questions and do that like on a Thursday. We'll have a bunch of questions, whatever questions you have. And then once class is over, I'll post the quiz and you just turn it in by the end of the day. For an exam day, I'm like for tomorrow, my plan is just to post the exam in the morning. And then you just have all day to work on it using the same resources you normally would, your calculator, the inverse trig function derivatives, and that's it. And then just post your work to the Dropbox, and we can talk about that too. So that is my plan, to do videos for the lessons, and then we'll have twice a week, we'll meet for an hour to answer questions, and maybe do some additional examples. If there are no questions, I'll have some examples prepared that we can do. And then we'll have quizzes and exams will be submitted through D2L. All right, so Allie, you have a question, or you were practicing raising your hand?
I was wondering if you're planning on making the exams any more difficult, since that, like, if we have access to our notes.
Right. So I have a challenge there, is like how to write them right. And so my tentative plan is like, there's no way to test derivatives if you can use all the tools at your disposal, because you can just go online and take derivatives. So I have to have a little bit of trust where I'm just going to say, hey, when you're taking the exams and quizzes, just have your calculator and whatever formulas we were allowed to give. And that's what I'm expecting that you would use.
Okay.
Yeah, because it just isn't practical. Like if we just had all these chain rule derivatives, you know, I mean, it's 2020. You can just type those in online, but that's the content. So I don't know, like I can't make it super crazy difficult. I don't know. It just doesn't seem like a good solution. I've thought about it. And so my general plan is just to say, you know what, I have to trust that students are just going to treat it like a regular class and do their best. If I was designing an online class, I would design it differently. But I had 2 weeks and we're trying to make it through here. So that's my plan, is that you'll try to treat it like a regular testing environment. Now you do have unlimited time, which is nice. But that's my plan. Does that answer your question, Allie?
Yeah.
I saw Albert next.
Mm,
Did you have a
yeah,
question,
can
Albert?
you hear me?
Yes, I can.
Yeah. What do you call it? So there's no more that 2-hour window to do the test?
Yeah, I think even a small, like it seems generous, like, oh, you could have 2 hours to do it, but you know, people's work schedules change. People got different jobs, and I don't know. The more I think about it,
I was gonna like question it because I do have like work at like 9:30
yeah,
too. Because I was
right.
debating like even on class time, like I have work too, so I have to like change my work schedule too.
Yeah, so I totally
So
get it. That's why like these sessions are optional. And the more I thought about the window, like, it just seems bad idea to have a narrow window.
I
So
mean, I don't mind personally. I just have to prioritize, school first, right?
for sure, yeah. I mean, so yeah, so these classes are, you know, I have to pick a time to if we're going to have a live session, might as well have it when we usually would meet. But they're optional. And then for the more I thought about it, I totally agreed with you. Like people have other stuff, their schedules have changed, they have family commitments at home. And so that's why the exam windows and quiz windows will be really big. It'll just be like post in the morning and due by the end of that day.
All right, sounds good.
Yep.
Thank you.
Yeah, no problem. Hey, Alexis, how are you?
Hi, good morning.
Good
I'm doing
morning.
good, thank you.
Good. All right, I see Haley has a question. I'm going to unmute you. Go ahead, Haley.
Are we still gonna meet tomorrow for our class?
No. So because tomorrow is the test day, we would not meet tomorrow. And the reason we're meeting today is I was originally going to meet Monday through Thursday. And then like I was working really hard this weekend, like getting all my class schedules up and like realizing I have to record all these videos for my other class. And then grading is going to take like 3 times as long to grade. Like it's so easy to grade and flip pages, but grading on a computer is just not. So I'm like, that's not sustainable for me to meet 4 days a week. So that's why usually we'll do Tuesday, Thursday. And we can talk about in the future what to do during exam weeks. Maybe we would still meet Tuesday, Thursday and just post the exam after class, you know, use that time. That seems reasonable to me. Definitely on quiz weeks, we'll still meet and then we'll just post the quiz after class. So I got to be honest, I have a plan. I'm not sure if it's a good one, and I'm totally open to suggestions. So if you have things that you think will work better, I am totally all ears here. We're winging this as we go. All right. Does that answer your question, Haley?
Yes.
Okay, sounds good. I see Nick. I'm going to unmute you here. Go ahead, Nick. Wait. Okay, now you're unmuted. Go ahead.
So I was just wondering, will we still be given feedback on tests and quizzes? And
right, that's what's going to take so long. That's what's going to take so long.
Gotcha.
I have a tablet, and so what I have here, I can show you. Like I have OneNote, and so I can like download people's work. I don't know if I have any in here. I had somebody had emailed me some work, and so I can download this. And I don't know if can you see this right now?
Yeah.
So I can download it right on the top and like give grading feedback and stuff like that. I can stop sharing this, but that what happens is I get individual. I get individual files from people that I upload, and then I make comments on them, but then I have to like download them as individual files and then re-upload them as feedback. So that's what's going to take a long time is like that technological progress, but that's how you learn, right? Like you still you want to get that feedback about what did you do right, where could you have improved. And so I think that's really going to be crucial. So I want to try to maintain the original plan as much as we can. Some of my colleagues have switched to all online homework, and maybe that would have been good because they give you feedback too, but that just seemed like too much of a change for me. So I did not do that.
All right.
Yeah. Yep. That's a good question though. Anybody else have questions? You can, let me see. Do I have the chat up? I have the chat up too if you want to comment in the chat. Yeah, Devante, go ahead, man.
So like, are we like submitting our exams like after you post the exam? Are we like printing it out and then doing work?
Yeah,
And then
here's how I'd recommend doing that. So you don't have to print out the exam. The exam is actually just going to be a list of questions. So you don't have to have a printer for this class. It's nice if you do. You could, you can print some stuff out, but you don't have to. It's just going to be a list of questions. You just use your own notebook paper. And then what I'm going to ask for you to do, and this would make life easiest for me, is if you use an app to take some pictures. And I recorded a video. I posted that in D2L. Let me see if I can share my screen again and show you where that is. But you're going to upload them to a Dropbox. And then that's how you're going to upload.
like we did the homework? Like we did the homework?
Right, right. So,
okay.
Yeah.
So we're just going to take a picture of it?
Mm-hmm, exactly. Yep.
Okay.
Yep.
Okay,
so, yeah, so everything will be in these Dropboxes. And you'll just scan and upload files. You can see a bunch of people have been doing this PDF practice. So I wanted you to do that to practice. Have you done that yet?
Yeah.
Did you try that?
Yeah, I have. Yeah, I have.
Yep. So that's how all your work's going to be submitted for the rest of the semester.
Okay.
And then the cool thing about that is when you submit there, I download that file, make all the comments, and then I can like upload feedback right in the same Dropbox. So once grades are uploaded, yeah, you'll be able to go into the same Dropbox, look at your document with comments on it. So yeah, so that's my plan. Yep. For anybody who hasn't seen that, there should be a YouTube video. Oh, I have so many videos. But there is a YouTube video. Hey, Chantal, we have an additional guest today. There should be a YouTube video. Maybe I should post it under the course resources about how to use one app that I like is the Adobe Scan app. It's just an option. There are lots of good scanner apps, but that's going to make my life easier. All right. Any other questions about the class, about how things are going to run so far? That's going to be too cute. I don't know if I can handle this, Chantal.
We woke up very energetic. She's a little too much for Big Brother to handle right now. Sorry.
It's all good. It's all good. It's funny. I've seen some posted like recommended like rules for virtual classes, and some of them are like, this is not real life. Like, don't have anybody in the background, and don't come and go, and don't be doing. I don't know. It's like, I don't know. I'm going to have interruptions at some point this semester for sure. So it's all good. We totally understand. All right, last call, at least for now. You can always ask questions later, but anybody else have additional questions about how the class is going to run? And you can type them in the chat if you're having issues, kind of raising your hand and stuff.
I have a question.
And so Sydney, and then I saw Alexis raise your hand too.
Did we get, I don't know if you already answered that, but did we get our quiz 7 back, or are we going to get it back?
That one is tough. So I would have to individually take pictures of all of them and upload them.
Okay.
So I do have the key posted in D2L under, I got it up here. It should be under Unit 3. There should be a key to Quiz 7. And so I've got them graded. But I think to see the correct way to do it, that's going to be our best method for that particular one as we transition from. And I was like, I just didn't want to take all those pictures. I'm sorry.
No, it's fine. Thank you.
Yeah, no problem. All right, Alexis, I'm going to unmute you, and you can unmute yourself if you ever have questions too. But go ahead, Alexis.
Okay, thank you. So, are we still meeting at 1 o'clock today, or is it just this?
So today, maybe I said 1 o'clock. So today, my schedule is, so our meetings that when we will meet will be at the regular class time. So
Okay.
I don't know if I typed in 1 o'clock because I have a stats class at 1 o'clock and I may have like crossed my paths and typed that at some point. That is definitely possible. So we'll meet at our regular time. And then moving forward, so this week's going to be a little weird because I changed my plan like yesterday. So normally we would meet on Tuesdays and Thursdays, and we'll meet for like an hour. We'll go over the notes. We'll go over homework questions, whatever you have. And then if we have a quiz or an exam, we'll just post that after that class period. This week, I was originally going to meet Monday through Thursday, which is why we're meeting today. So tomorrow we will not meet. And then we can go ahead and meet Wednesday and Thursday of this week. That's okay. And then moving forward, we'll just meet Tuesdays and Thursdays at the normal time. But I do have additional time when I would be online, and that's what I was going to look up here. It's in the syllabus too. Let's go back. I should just leave the screen share on. The thing about when the screen share is on, then you can't see everybody, right? Or it's like harder to see everybody?
You can still see everyone.
Okay, all right, that's good. So in our syllabus, I have some times where I will be online also, just available to answer questions. So those are, I have like a 4 p.m. because I took over, this is even crazy. I took over another section for an instructor, a colleague who had to take medical leave. So right as we transitioned to a global pandemic, he had some heart issues and had to leave for the semester. So I'm doing this evening class too. So I have some at 4 on Mondays, and then Tuesdays and Thursdays after class, I'll be online and available. But the only class time we'll have is at 9:30 Tuesdays, Thursdays.
Okay. Yeah, that sounds good.
Good
I just kind
questions.
of was a little confused on that.
For sure. And there's going to be lots of questions. And I think, honestly, I feel like whatever plan, if things change, like a couple weeks and we'll get in a rhythm, and it'll be a new rhythm, but I think we'll get in a rhythm and we'll get comfortable with what the new plan is. So that's cool. All right. Anyone else? Oh, I see Brittany. Go ahead. She's good at raising her hand. I'm going to unmute you. All right. Go ahead, Brittany.
For the Discord chat, is that
Yeah.
where we would put questions when we're not in class?
That's
or
what I was
like if we're
thinking.
doing work?
Yeah, someone had requested that. I don't know if it was this class or another one. I'm like, it's kind of a good idea just to have some place to post questions, and I can answer them there, or other people can answer them there. So that's what I was thinking, where it's like an asynchronous homework question chat where don't have to be on at the same time. And there is a little, I haven't used it yet, but there is the ability to actually voice, like talk at the same time. So like if I'm online then, and I have the Discord up, you can go in and like we can call each other then too through the Discord. So I don't know. I have never done that before. So I'm learning a lot of new stuff. We'll see how it goes. But my idea was that you all might be able to answer each other's questions, or, I think if I just have it up, it like pops up an alert if somebody posts there. Does that happen one time for one of my other classes? So we'll see. Cool. That was good questions. Anybody else?
Oh, I also have another question.
Yeah, go ahead.
Are you posting the notes online?
Yeah, so we're going to switch, and we're not going to use my notes anymore. We're going to use Dr. Sugar's notes. My colleague, Dr. Nicole Sugar, she's teaching this semester as well. She uses a similar format where she has guided notes. They're not as awesome as mine, but I'm just saying.
Okay.
No, they're really good. She's taught this course many times. So if you look here it should be under each unit. No, sorry, not unit 3. We're already in unit 3. Under unit 4, you'll see chapter 4 notes from Dr. Sugar. And then
Gotcha.
there's videos for each section. Right. And so,
okay. So
what
like,
I'll do is
okay.
I'll say, hey, we're going to meet again on Thursday. Why don't you watch 4.1 and 4.2, those 3 videos, and do those notes by Thursday. So that's the kind of thing.
Gotcha.
Yeah. Yep. That's how it will work.
Okay.
Yep.
Okay.
Cool. Albert?
Oh yeah, this is about the class today. Are we gonna finish up the 3.5 notes?
One thing I definitely had is I wanted to do another Newton's method example with you all. And we can just maybe do the one from the review and just kind of practice the calculator sequence there.
Because that's like what I have trouble right now.
Does anyone need a calculator? because let me know if you do. Because can't I get this to attach? That's weird. Where did the chat go? I lost my chat. All right, no one's. I have too many windows open here. TI, Texas Instruments, is letting people download their emulator for free for the next 6 months. So, oh, I don't know who that is. Who is Lauren? Oh, it's Lorenzo. Ah, I figured it out as soon as you said. Yeah, so Lorenzo, maybe you can, let me see here. I think I posted it. Oh, what's happening? I think I posted it here. Did I? No. Where did I post it? I can't remember. I remember looking at it. So let me post it right now. I have too much up here. Texas Instruments. And so this is just I don't know if it works on a device. I know it works on the computer. All right. So if you follow that link, you can download free. I put it in the chat. So if you see that in the chat, did you see? Yeah, Lorenzo is in the chat already. So if you need that calculator, you can contact me too if you need help getting that calculator installed. But it looks pretty cool once you have it. I can show you here. I see you, Alexis. I'll get back to you. By the way, Alexis, if you tap on your screen and click on the manage participants, then there should be a way to raise your hand. You can actually raise it. You don't have to like physically hold your hand up, you know?
Okay, I think I just figured out how to unmute it. But so for iPhones, you can download an app. It's called Calculator X, and it pretty much looks like this.
Nice.
Or if you have Samsung, it's called Wabbit Emu.
That's I've used that one before. I have it on my Wabbit.
So those work really well.
Yep. Wabbit Emu is like an emulator. I have that one.
Mm-hmm.
Yep, for sure. Okay, I have my calculator up, but where is it? Oh, it's okay, there we go. The zoom is always on top. So if you have this on your computer, it's pretty sweet. You can use the emulator here too. So a bunch of options there. And that's free to download if you need a calculator. Lorenzo, did we answer your question? You got at least something to investigate?
So my question was gonna be
Oh, you have another question. Sorry.
yeah.
It's all good.
Yeah, so the Discord chat, can you update the invite? Because you have to update that like
Ew. I
usually
thought I
after.
posted one. Let me make a note for myself of things to do. I tried to click one that like didn't expire because I know there's an option to have an invite that doesn't expire. But I'm gonna start. I had like this long list the other day and I did pretty good. I just have like one on the bottom that I didn't get to. It's not bad. So now you're the first item for today. So I'll update that. And I'm still not sure, like, is that the link to the chat or is that just a link to sign up? I'm not sure about that. So we'll figure that out. I don't know, but I'll do that for sure. I know, I do remember seeing that there was an option like, oh, this will expire after 24 hours, or you can do never expire. So I might've put the wrong one there. Cool. All right, any other questions before we dive into some Newton's method? Okay, let me know if you do have any questions. I have the chat up and everything too. So let's do this. I'm gonna pull my calculator out of the way for now. All right, so let's go into the practice exam. Hey, look, there I had up Newton's method. I think I suspected that that's what we would be talking about. So I wonder what is best here. I'm gonna try, this might go horribly wrong. Try to flip, I have this convertible laptop. You can like flip it over and it's a tablet. It's kind of cool. All right, so here's a typical example here, number 20. This is in the practice. Is that too small? Can you see that okay on your screens? It's all right. You can try to zoom in. I know it's not, I don't know what kind of computer everybody's on, but this is what Newton's method is for. It's for approximating zeros. And let me get up another window here. Just hold on a second. Just to kind of show you what we're going to try to do, let's graph that function. What was it? X cubed. Was it plus x minus 1? Is that what it was? Yeah, x cubed plus x minus 1. And you can see here there's a 0 right here. There's this 0, so it's about 0.682. And so what Newton's method is a way for us to actually estimate that 0. And it's not something that we can get by factoring. This is a cubic function. How do you factor it? Not easy at all. And so let's go and show how this works. So the idea here is you start with an initial guess. And one thing I did for this one when I did my key is I said, well, if you do f of 0, that's 0 cubed plus 0 minus 1, that's -1. If we do f of 1, that's 1 cubed plus 1 minus 1, that's +1. So you know somewhere in between there, there's a 0. Haley has a hand raised here. Hold on. Go ahead, Haley.
Okay, so I had a question on how you knew to use 0 and 1, because the other questions gave us x1 and they gave us the value for that.
That's a really good question. And I was thinking about that as I was writing it. I'm like, oh no, I didn't talk about that. So I'm glad you asked. The way that I knew that is just experience. So what I'm trying to do here, if I don't have a hint, what I'm trying to do is I'm looking for 0. So I'm trying to think in my head, is there some kind of obvious one that would give me a negative number and an obvious one that would give me a positive number? And I'm just trying to think through that in my head on what those would be. The other option is, I know the homework ones usually gave you a starting option. So if there isn't a starting option, it's going to be functions that are pretty easy for you to look at and get an estimate for. And you have your calculator, so you can always use your calculator too to say, well, it looks like it's a little more than 1/2, so I'm going to start at 1/2 and then see where that goes too. So you can use your technology to your advantage too.
Okay.
Yep. All right. Let's see here. So let's just choose, since it looks like it's somewhere in the middle, let's choose our first one to be, I don't know if we label it x1 or x0. Doesn't really matter. Let's choose our first one to be 1/2. Then we have a Newton's method. Now, unfortunately, we're just starting our notes now, and I don't have copies of the old notes with me. I have them in paper form in a binder on my desk here, but I can't like pop that up, unfortunately. So, oh, maybe I could. This will be inefficient here. But there's a formula that you're going to need. And if you want to, you can feel free to write this down. I do not mind if you have this Newton's method formula written down. Where did mine go? Oh, I'm in the notes here and I can't find it. Well, I don't know where it went, but I do have the old one here. So this is the formula we want to use. This guy right here. So this is our Newton's method formula. So I'm going to write it down. I'll write it down on the screen here. So our next guess, the next one, is the previous one minus the function at the previous one over the derivative at the previous one. So what you're going to do is you're going to create a sequence of values here where they get closer and closer and closer to what the 0 is. So we have our function. We need to find the derivative. F prime of x, that's easy enough, 3x squared plus 1. So what I like to do here is I actually like to write the formula out. So the formula will be x sub n minus the function there, So x sub n cubed plus x sub n minus 1 over 3x sub n squared plus 1. So that's our formula. We're just saying it's the function over the derivative. And the subscripts here are nice. If you kind of were totally lost on the subscripts, you just said, you know what, I'm just going to write x. It's fine. It's a little confusing because you'd have x equals something in terms of x. So that might be a little confusing. They're really different x's. The one on the left is the next x, and the one on the right is the current x. So, but if you just got lost with the subscripts and just wanted to write x for all of them, that would be okay. That's not the end of the world. And in fact, that's what we're going to do in the calculator. So here's how we do this in the calculator. First, we have to store our first x, and there's a little arrow button as x. So let me show you how to do that. Hopefully you have your calculator or an emulator handy. Let's see here. I can make that a little bit bigger. I think I can even do this to make it even bigger. Nope, that's like that. There we go. So I'm going to do 0.5, and then on the bottom left, there's an STO, and you store that as x. So you take your initial guess, and you store STO on the bottom left here. I wish I could like zoom in. But on the bottom left, there's an STO function, and you store that as x. So what that does is that stores your initial guess, whatever your initial guess is. Then you want to type in the formula that you came up with. So you can see here we have this x minus all of this jazz. So we're going to type that in next. So we're going to type x minus, and then the numerator, which was x cubed plus x minus 1. And then divide by the denominator, which was the derivative, 3x squared plus 1. Yeah, that's the derivative. Now here's the key. So what this will do, if I hit enter right now, this will calculate the next x, which is great. But what I wanted to do is I wanted to like do it again to get the third x and the fourth x and the fifth x if needed. And I don't want to have to like type it in every time. So here's what we're going to do. We're actually going to take this and we're going to make like a circular thing. We're going to store that result back as x. So what it's going to do is it's going to take 0.5, plug it into the function on the left. So it's going to take 0.5 and do 0.5 minus 0.5 cubed plus 0.5 minus 1 divided by 3 times 0.5 squared plus 1. But then it's going to take that and store that back as x again. And the reason why you do that, so I hit enter. There's my next guess. 0.7143. So let me write that down here. So x1, whoa, what happened? Oh, I scrolled over to the right. I did like, how did I do that? I don't even know how I did that. All right, so we have our first guess is 0.5. Our second guess, I'm going to say approximately 0.71. Oh, wait, what was it? 7143. Now, the reason why I'm stopping at 4 decimal places, I probably could have stopped at 3 decimal places actually, is because that was my accuracy. I want to be within 1,000th. So whatever your accuracy is, that's where you stop. So I want to be within 1,000th. Okay, now here's how this calculator is beautiful. Now that new thing is x. So if I hit x and hit enter, it has this new thing stored as x. So what I want to do here is I want to go second entry. I want to go back again. You shouldn't have to do this, but I want to get that same one and just keep running it again. So if I hit enter now it's going to do it with the new x. And so you just keep hitting enter until they all agree to whatever you want them to agree to. So now it's 0.6832. X3 is about 0.6832. And then just hit enter again. 0.6823. We don't quite agree to 3 decimal places. You can see they're still different at the 3rd decimal place. So we have to keep going because we want them to agree to the 3rd decimal place. All right, so we just hit enter one more time. And there it is, 0.6823 again. And so we agree to the 3 decimal places, which is what we wanted. So we would say x is approximately 0.682. And that's the answer. So let me clear that calculator and just show you the process from the beginning. So first we store our initial guess. We store that as x. So the store button is on the bottom left. It's really small on here. I'm sorry, I can't really make it bigger. So this STO on the bottom left, you store that as x, you hit enter. And then you type the Newton's method formula. So x minus, and then the numerator, which is the function, over the denominator, which is the derivative. So x minus parenthesis x to the third. I guess, can I like type on the screen here? X to the third, yeah. Minus, no, plus, sorry. Plus x minus 1 divided by 3x squared plus 1. And then you're going to store, this is the key, store that as x. And then all you do is just keep hitting enter. Enter, there's the second guess. Enter again, there's the third guess. Enter again, there's the fourth guess. Enter again. And they agree to your desired accuracy. That's your fifth guess. So you just, if you get it typed in correctly, you just keep hitting enter, 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 enter. So I don't want you to worry about the technology or the formula. I just want you to be focused on the process and making sure you have the right derivative. Okay, I see a question from Lorenzo. Go ahead. Let me unmute you. Go ahead, Lorenzo. Hold on. I'm having unmuting problems.
Yeah, so I'm still confused why we chose 0.5.
That's a good question. So one way, it's kind of the question that Haley asked earlier about how do we know where to start? You have to get a starting point. Often it's given. I don't know if you've been looking at the homework, they often will give you a starting point. And so if you're given the starting point, that's your starting point. We also had the graph. So we have this Desmos graph and we say, well, it looks like it's kind of near 1/2. So we could just try 1/2. And then the other thing I did was I said, well, you know, just because I have a little bit of practice, I look at this function like, well, how could I get a negative and a positive? If I can get a negative and a positive, I know it's between them. So I just thought like, well, if I put in 0, that's -1. If I put in 1, that's +1. So it has to be between 0 and 1. So there's no one answer about how to know where to start. It's easiest if it's given to you in the problem. In reality, if you're looking for zeros, you know, you don't always know. Life doesn't say, hey, it's approximately 1/2. So why don't you start there? You know, you have to kind of figure it out. So I would use my graph to get a good starting point.
Okay.
Yeah, I think that's a good way to get a good starting point if it's not given to you. So yeah, good question. All right. Anybody else have a question now that we've done one of these examples with the calculator again, step by step? Any other questions? And if I can't see you and you don't know how to raise your hand, you can type in the chat also. If you'd like to know how to raise your hand, depending on your device, you should be able to click on or tap the participants, and then there's an option to raise your hand once you're in that screen. So, Chantel, go ahead.
For when it comes to the exams, being that we're doing a lot of this like on the calculator, do you want us just to write out the formula and then we can put the table like you have on the right-hand side just to show we are continuing to get the answers?
Correct. So, and I should probably do that. I think I've done that in past tests where I've said, write your formula and then write all of your successive guesses.
Okay.
So you do not need to write out the calculations that you did.
Okay.
So let me highlight that here. What's a good color? Oh, I can highlight. So I want to see, oh, that's cool. I want to see the formula, and then I want to see all the successive guesses. and then I want to see your answer. Cool. All right, any other Newton's method questions? I don't know if it's bad. I kind of like doing this on the tablet. Is that bad? Like, I'm kind of enjoying the tablet. I like the different colors. It's easier to use. It's easier to switch screens. And then we don't have the, remember how we like, if we wanted to switch from Desmos to the notes, there'd be like this long delay when turning the screen back on. I don't know if you remember that. That was super annoying. I don't have that now. I can just switch back and forth. Bloop. Bloop. That's cool. Haley has a question. Let me get back over here. Okay, Haley, go ahead.
How would you calculate a problem that doesn't have an f of x? Because one of the examples in the book is, and from our notes, is square root of 2.
Mm-hmm.
So how would we calculate using Newton's method?
Yeah, you have to make your own function. And you have to make a function that would be 0 at a specific point, right? So the challenge for that one, let me see, can I make a new page here? Yeah. So the challenge for that one is, how do I make a function? If I want to approximate square root of 2, well, I need to make a function that I can apply Newton's method to, and Newton's method only finds zeros. So you have to make a function where you're looking for it to be 0. So what we did is we said, well, if we squared both sides, x squared would be 2. And if I subtract 2, this would be like solving x squared minus 2 equals 0. And now I have a function on the left, x squared minus 2, where I'm looking for its 0.
Okay.
So those are definitely more challenging. You know, I think the easiest Newton's method is, here's a function, approximated zeros, start here. That's the easiest. Second level is, here's a function, approximated zeros, like we just did. And then third level of difficulty is, approximate this thing. You have to make your own function. You have to figure out where to start. You know, that's the most challenging of Newton's method for sure. All right, does that help answer your question?
Yes, but why wouldn't you write it as, could you write it as y equals square root of x? Or would you not want us to write it like that?
But you're not finding a 0. So Newton's method only works for zeros. It has to be equal to 0. It has to be equal to 0. So it has to be some function that you're trying to find out, where is it equal to 0. That is the only thing Newton's method is good for, is finding zeros. Cool. All right. Any other questions about Newton's method? Oh, there's Sydney. Sorry, I missed your hand. Did you unmute yourself? Okay, here you go. Okay, go.
Sorry. So with this method, would you like setting it up as x equals square root of 2? Like, would you, if we were given something other than square root of 2 to try to do this with, like, would you suggest just making it equal to x and then like solving for 0 in that way?
Right, and then kind of like, how can I make a new function? Like, say I want to approximate the cube root of 3. You could do the same thing. Well, say, well, I'm going to let x be cube root of 3. If I cube both sides, is x cubed equals 3. And so then I have a function x cubed minus 3 equals 0. And now that
okay, so it would more just be like with a number?
Yeah, yeah.
Okay.
Yeah.
Okay, cool. Thank you.
Yeah. All right, what else? I have the study guide up. Does anyone else have any additional questions you wanted to ask from the study guide? Sorry, I'm going to scroll up to the beginning here. Lorenzo, go ahead. Oh, wait, hold on.
Good.
All right, you're unmuted. Go ahead, sorry.
Oh, okay. Can you go over 22?
Oh, yeah, so I think those last 2 topics are going to be the most challenging here.
Yeah, I don't get both of them are kind of confusing.
Sure, sure. We could do 21 as well if you like. The key here is, you remember the tangent line, you have some function. So you have some function like this. And say we're looking at 2. The tangent line, if we were to zoom in, that's a terrible drawing. But if we, oh, I'm having issues here with my zoom. So you see here, if we zoom in, I mean, my line was pretty bad there, but it's pretty close to the function when we're close to 2. So the idea is the tangent line's a pretty good approximation if you're close to where the tangent line is centered. So if you're close to 2, the tangent line is pretty good. If we wanted to approximate it over at 0, the tangent line would be really bad over there because the curve has since moved on and the tangent line is no longer good. So the idea is that the tangent line is a good approximation if you're close to the center. So what I did on this one is I wanted to find a way to ask that. And so I kind of made up some notation where T sub C is the tangent line at C. So T sub 2 would be the tangent line at C equal 2. So that's this curve I have right here. That's I just kind of made up this notation there to say, okay, that tangent line is the tangent line at 2. T sub 4 would be the tangent line at C equal 4. That's a different tangent line because it's a different C. So that's over here. Again, I've just made up this function here, but here's 4. Here's a tangent line. We could actually do, what do I do? I have all these fancy colors. Do that one in a different color. Let's do red for that one. So there's 4. There's a point up there. There's a tangent line. So then the question is, which of these would be better approximations? Using the T2 tangent line, whoa, I'm not sure how that happened. Using the T2 tangent line, let's maybe draw that one in green. Uh-oh, too much erasing. So using this green one to approximate the function at like 2.05, or using the red one to approximate it at 5.87, which would be way over here somewhere, right? 5.87. Which one would be a better approximation? So again, the key is the tangent line is a good approximation if you're close to the center. So the T2, the center for T2 is 2. And so 2.05 is pretty close to 2. So that one's going to be a pretty good approximation. 2.05, pretty close to 2. For the T4 at 5.87, 5.87 is pretty far from 4. So that one is probably not going to be a good approximation. Not as good. So all this one was asking is, well, since 2.05 is pretty close to 2, that one's going to be a better approximation than the 5.87 being close to 4, since it's farther away from 4. So that's what that one is asking. Does that answer your question, Lorenzo?
Yes.
Maybe. That was an unconvincing yes.
Yeah, I just wouldn't understand how to explain like how you know.
Yeah, it's all about how close you are to the center. So you know 2.05 is closer to 2 than 5.87 is to 4.
Yeah.
That's how you know. You can just write those words.
Oh, okay.
Yep. This is like a words explanation. That's it.
Okay.
Mm-hmm. Yep. Okay. Allie, I see you trying to unmute. I feel like I have to click it like 3 times. Okay, go ahead.
So this example only works if the points 2 and 4 were already picked.
Yeah, I had to give you those. Otherwise, it doesn't really make any sense. Because you can't say, well, which one does a better approximation because you don't know what the center is. You have to know where the tangent line is.
Okay, so does that mean if we got an example like this on the test, we would have like, it would kind of be variable answers because we'd have to draw our own graph?
No, that's a good question. You don't, the idea is like, I could draw a graph where 5.87 is actually perfect if it's a line. So there's no, that's why this, if you look at the question, it's worded a little vaguely here. It says, which would likely be a better approximation? So it actually, the idea is the graph is not required here at all. To Lorenzo's point, the way you would explain this is, well, if I'm using a tangent line, 2 is closer to 2.05 than 4 is to 5.87. So the 2.05 is going to be closer to that tangent line start. So that's why that one's going to likely be better. And that's all you would need to do is you just want to remind yourself tangent lines are good approximations if you're close to the center. You're close to where the tangent line touches. And that's the only concept that this one is trying to get at. Does that answer your question?
Yeah.
You both have very unconvincing yeses.
I think I just need to see another example problem to fully get it.
Well, we could do a graph here. Well, I have this function up here. Y is equal to x cubed plus x minus 1. We could find its derivative. I think if I do this here, let's do this. Call it f of x. I can do f prime of 1, and it gives me a slope. And so I can actually do the tangent line y minus, what would it get when I put in 1? Y minus 1 equals 4 times x minus 1. All right, and that touches at the point 1, 1. Can we see that kind of? So the idea here is, suppose I want to use the tangent line. I'm going to redefine this tangent line. I'm going to call it plus 1 on the other side. And I'm going to call it, I want to make a new function. I'm going to call it capital T of x. It's the tangent line. So suppose I want to use this tangent line to approximate the function. So what do you think would be a better approximation? T of 1.1 versus f of 1.1? Or T of let's say 0.65 and f of 0.65. So can you see which one is better? I know the screen's kind of small. Can you see which one does a better approximation? The tangent line at 1.1 compared to the function at 1.1, or the tangent line at 0.65 compared to the function at 0.65? Can you see which one is closer?
Not really.
See, tangent line at 1.1 gives you a function value of 1.4, where the function value is actually 1.431. So not bad. You know, it's off by 0.03. Where if I go to 0.65, the tangent line is -0.4, but the function value is almost 0. So it's a lot further there. And the reason is, because we were further from the edge of that center. So if we look at 1.1 f of 1.1, and we look at 1.1 and the tangent line at 1.1, we can see that those points are very close because we're pretty close to 1. But if I go over on the left-hand side, I did 0.65 and f of 0.65. There's the function value. And if I do 0.65 and the tangent line at 0.65, they're further apart. And the reason they're further apart is because I'm further from 1. The closer I am to 1, the better the approximation is going to be by using the tangent line. Okay. So the tangent line is only good close to the center. The further away you get, it starts to split from the function. So that's the main point we were trying to make there for that one. Does that help a little bit?
Yeah.
Okay, good. All right, that was a good question. What else? What other questions from the exam practice? By the way, I'm recording this. I'm definitely recording this. And so, you know, if you have to go, it's 10:30 right now, but if you have to go, it's all good. We'll record it, upload, you can watch the rest of it. Lorenzo, you had another one. Go ahead.
21.
Oh, yeah, we were talking about doing 21 too. That's right. Let me get back into there. So this is the idea of differentials. The idea for a differential is you basically you think of the derivative, dv with respect to r, and it's this derivative, let's see, 4/3 pi, and then the derivative of r cubed would be 3r squared. The 3's can simplify there, so we get 4 pi r squared. That's the derivative. The differential idea is you essentially treat the change in volume and the change in radius to be individual variables, and you multiply both sides by dr, and so it's 4 pi r squared dr. That's the differential. What this is this is a way to estimate. This is similar to the tangent line. It's the estimated change in volume. Sorry. See, it's even easier to erase on here too. I just click a button on my fancy pen and then I can erase. I might like next fall, and when I go back to the classroom, I might like bring my tablet and do this instead of having the handwritten notes. So this is what differentials are for. This is when you have a small change in your independent variable. Notice here, the volume depends on the radius. So we want to know how much will the volume change if the radius changes a certain amount. That's what differentials do. They approximate the change. So here, let's see, the change in volume, the actual delta V is the actual change. Will be approximately to the differential, which is 4 pi, and then the radius, it started at 8, and then there's a possible error of 2/100ths of an inch, so that's how much the radius could change, 2/100ths of an inch. The radius is 8, so we have 8 squared, and then the dr is the change in radius. So this is a little confusing here. Let me make this a little bit clearer. The whole dV is the estimated change in volume, and then the dr is the change in radius. So our change in radius is actually could be positive or negative because it's an error. So it could be, what they're saying is the radius could be as low as 7.98 inches or 8.02 inches. So plus or minus 2/100ths of an inch. So plus or minus 2/100ths of an inch. And then we just calculate that. I'm gonna just hop over, where'd my calculator go? I'll pop back to the screen there in a second. 4, where's the pi? Pi, radius was 8. The downside of this, I apologize, when I look down, you just see like glare off the top of my head. Just bald spots coming in. Times point, I'm just gonna put 0.02 because it could be positive or negative. So we'll just put positive or negative. So we get about 16.08. There's not a lot of guidance on this one. We should have given some guidance on how many decimal places to use. But we'll say plus or minus 16.08. And if you're looking at the units, 8 is in inches and the 200ths also in inches. So you're going to have inches squared times inches. So you'll get inches cubed. So what this is saying is that, by the way, you're not hearing my computer, like I'm getting dings when I'm getting emails. Are you hearing those? Okay, good. And I tried to turn that out. You don't want to be hearing dings I don't want to be hearing dings when I get emails, but I don't know how to turn it off. So it's all right. So it's what this is saying is if your radius is off by at most 2/100ths of an inch, your volume could be off by at most 16.08 inches cubed. So that's your change in volume, your kind of error in volume based on an error in radius. The process is going to always be pretty similar to what we did here at the beginning. The differential is basically you take the derivative, but then you're treating the dv and the dr as like actual variables, and you're solving for dv. And that's what the differential is. All right, anybody have additional questions on that one? All right, again, I know you got places to be. Feel free to take off if you need to. I can take about 10 more minutes. I think that should be time for 2 or 3 more. So who else has one that you wanted to work on together? if you haven't seen the key, I have a lot of windows open. It is in D2L. And under, I think it's linked from the home page, but it's also, yeah, it's right here too. It's the Unit 3 exam study guide key. It's also under the Unit 3 folder. You can see it there too. So if you need the key, check your work, email me or post if you have any questions. I see Brittany has a question about number 16. Did you try this one, Brittany? Did you find a derivative yet?
So I followed you up until the, like I got the actual derivative portion of it, the first
Okay.
half.
Mm-hmm.
But the issue I had was when I plugged it in for the tangent line.
I
That's when
think mine might have been wrong. I fixed it because Haley emailed me last night. What did you get for your slope?
well this
I mean, you need a calculator because it's this ugly, terrible number.
yeah, it looked, I know I did it wrong because I got like 1 and 3, so I think I did it completely wrong. So,
Okay, all right. So let me copy down because I don't want to recalculate everything. I'm going to try to cover up. Oh, it kind of shows the answer there. Because what I really want is just this dy dx, right? That's what I really want.
right.
Can I like, oh, no. I was trying to like grab this. All right, that's not working. Okay. So let me see if I can just copy it down. Can you, Brittany, can you unmute yourself and then just read it off to me to remind me what it was? Ah, gosh.
It's 8y minus 3x squared over 3y squared minus 8x.
All right. So that was using implicit differentiation. You can check the key for that. Now we want to find this tangent line right here. We want to find the equation for that tangent line. So we need the slope. And the slope of the tangent line is the derivative, dy dx, evaluated at our point, 1/1/8. So assuming we did this all correctly here before, which is not necessarily a good assumption, we want to plug in the 8, we'll plug in 1/8 for y. So this is different than our usual f of x, where we find f prime of x, because we have an x and a y. So we just plug in both the x and the y at the same time. So minus 3x is 1, so 1 squared over 3 times y squared minus 8 times x, which is 1. Right? And so we get, let's see, 8 times an eighth is 1, 1 squared. And let's actually just simplify that because this is going to be 1, this is going to be 3. 1 minus 3 is negative 2. And then 1/8 squared is 1/64. So we have 3/64 minus 8. And that's where I'm like, I'm just going to use a calculator. And let me check, see if I can do that. What was it? Negative 2 divided by quantity. Nope, sorry. Negative 2 divided by quantity 3/64 minus 8. Enter, and then math to fraction 128 over 509. Yeah. Yes. Okay. All right. Sorry. I don't tell my wife I said yes. Okay. We have these little like explosive paper fireworks, the snaps that you throw and they pop. So he wants to prank his brother, who's 8. This could end badly, but it's okay.
Mine's already stopped by twice, and Mom, can I watch a movie? Mom, can I get a snack? Mom, and I'm like, yes, just 2 seconds.
It's fine. It's fine. So that's our slope, 128 over 509, and I think that is what I got before.
Okay.
And then a good way to check this is to graph. Where did my graph go? There it is. Is to graph. Let's see, we want a new one here. Oh, wait, it was x cubed plus y cubed equals 8xy. And then we had, what was our y minus, it was 1/8 was the y equals, the m was 128 over 509 times x minus 1. And you're like, okay, yeah, that looks like a tangent line, you know? So it's a good way to check. This one you'd have to use Desmos. You can't use your calculator because you can only graph y equals on your calculator. So you'd have to use Desmos to check this one. Okay, so that was number 16. Anybody else? That was a good one, Brittany. Okay, so if you have any other questions, I can hang out for a few minutes. Otherwise, I think I'm going to end this call. So reminder, here's what I will do for the test. Tomorrow at 8 o'clock, I will post it on D2L, and it'll just be a PDF document, just a list of questions. You don't need to print it out. You can if you want. It's not going to be a test that you fill in. You just use your own paper. And then once you have that work completed, then you can, there's flexibility here. You can use however much time that you need. I'm expecting, this is what to Allie's earlier point, I'm expecting that you're using the resources you would have in class for this. So I'm expecting you to use your calculator. You can use your formulas. Remember, we have the inverse trig functions, their derivatives. You do not need to memorize those. So you can have, I would prefer that you had them written down on a separate sheet of paper or something. Maybe I'll put them on top of the test so you can have that open. Just so you don't, like if you have the textbook open or your notes open, it's hard not to see other stuff in there too, just because it's right there. So you can have those things open during the test. And we talked about, like for this example, if you wanted to use Desmos to graph, those resources are fine. And then you just complete the work, take a picture of your work, and then upload it to the Dropbox, which I'll have in D2L. And I'll have 11:59 p.m. tomorrow as the deadline for that submission to the Dropbox. Does anyone have any questions about how the logistics of that? Bless you, Chantel. Any questions about the logistics of the exam?
Are we still looking at approximately the same amount of questions like the previous exams?
Yeah, pretty similar. And some of these, like as we go in the semester, you'll see that the exams will actually get shorter in terms of number of questions as the questions become more in depth. But we don't, like, I plan for it to take students between, you got to give me 5 minutes, bud. Okay. Apparently it worked. He pranked him. It was really funny for him. I don't see his brother though. So I expect the exams to take between, some students will be faster, but take between 45 minutes and an hour and 15 minutes like they normally would. So that's my intent, is that they'll be the same length that they normally would. Not going to be longer or shorter. You'll see the points listed and everything. So, yeah. Tvante, did you have a question? And then I see Lorenzo has a question too.
Yeah, I had a question. Like with class time? No, not class time. Are you like making up the 2 weeks I missed?
Well, we technically just missed 1 week because we.
Oh yeah, so spring break.
Yeah, because technically last week was spring break, and so what's going to happen is we're not going to make up time. So the semester will still end at the same time. We're going to try to do a little bit of makeup for lost time, and then I've been having some discussions with some colleagues of a couple of sections that we're going to kind of shortchange. I'm just going to say, you know what, these sections we're just going to, maybe because Dr. Sugar is recording the videos, I might say, hey, save this video, fill out these notes, but we won't have a test question from that section. Maybe something like that. So there's going to be a couple of topics that we're just going to shortchange to make up for that. Yeah.
Okay, thank you.
Yeah, no problem. Let's see, we'll do Lorenzo. Go ahead, Lorenzo.
All right, so you said 11:59. Do you mean as in 11:59 in the morning?
PM.
Or
PM.
PM? Oh, okay. So it's all day?
Yep.
Okay, sounds good.
Albert? Hold on. I feel like I have to click unmute 3 times. And I don't know, maybe I'll just let you do it. Go ahead.
For logarithmic differentiation, like in number 18, like you want it as that final answer, and it'll plug in back y.
Yes. So that's a really good question. For logarithmic differentiation, you need to have, see how y for both of these, y is a function of x?
Yeah.
Then your derivative needs to be a function of x.
All right, sounds good.
So
All
you
right,
do
that's
need,
all I need to know. Yeah.
yeah, you don't need to simplify.
Okay, you don't need to simplify, but
no, but it needs to be a function just of x.
Got it. All right, that makes sense. Sounds good.
Yep, really good point. Yep, good. Anybody else? I'm not seeing any other questions. So feel free, email me if you have any additional questions. Try the Discord chat. I think we'll get in a rhythm with that, and that'll maybe don't stress about that right now, but if you have a question, you can post it there. Otherwise, I won't see you tomorrow because we won't have a class, but I'll post. And then what did we say? Do we want to do, I think I'm cool either way. Do you want to break and have Wednesday off to watch videos, or do you want to meet both Wednesday and Thursday for this week, since that's what I originally said we were going to do? Anybody have a preference? Should we do that? Okay, well, so we'll meet this week. We'll meet Wednesday and Thursday. And I had an agenda here, what I would like you to do. So I think I'm going to adjust that.
I got a quick question also.
Yeah, go ahead, talk while I'm fixing this here.
It says you have like online hours tomorrow. Is that valid tomorrow? Or no, just all test day, no online hours?
That's a good question. I don't have a good answer for that. The one thing is that I have to, my only concern is I want to be equitable for everyone. And so I can't like once the exam has been posted, I don't think I can answer calc questions then, because you can like, oh boy, there's another logarithmic differentiation one. I'm going to pick number 43 from the homework that's just like that and ask about number 43.
True. Never mind.
So it's tough because, I mean, other students might not do that, right? They haven't opened the exam yet. And maybe if I could find, I don't know. It just seems probably better to not do that. So let's keep questions to today. So do your studying today and then ask any questions that you want. I think once the exam has been posted, I just don't think it's fair to be answering questions anymore after that. But again, like, you might not have done the exam and you were just still studying. Like, it's not that I would like, oh, people are going to abuse it, but it's just hard to know. And I think it just creates an extra layer of complexity. So I think that's a good point. I'm going to post here, no questions once the exam has been posted. Maybe, should we wait to post it until a little bit later in the day? Or does it not matter?
It's up to everybody else. I mean, if people want to do it right away, that's good on them too.
Okay. This first one is the most awkward because like we just started up with this new format and like, hey, we're in a new format, test tomorrow. You know, like that's really awkward. And so it's a really, Sandra said no, but now I don't remember what the question was. Oh, posting it later. You said no. Okay. All right.
I say keep it as it is.
Yeah, we'll do that. I'm gonna be, by the way, this is like, I'm gonna be super flexible here. So like if your schedule changes or if you need to just communicate with me, shoot me an email, hit me up during one of the chat things. And like, this is all uncharted territory for all of us. And so it's not like I'm gonna say, well, you have to do this, you have to have your camera on you while you're taking the test. And we're gonna be really flexible. We wanna make sure you get what you paid for and that you're being supported during this time. So that's definitely going to be a priority of us, is like your emotional and well-being as well. So I don't want to add, you already have enough stresses. We want to make sure you're kind of doing the coursework and showing that you've learned the material without like adding extra super layers of stress to your lives right now.
And is Newton's methods formula given or no?
let's see here. I need to clarify what stuff will be given. So why don't I clarify on the exam? See, to me, that kind of thing is like, it's super easy to look up. So why
But
memorize
easy
it?
to mess up too, though. And
Right. But what I mean is it's super easy to look up. So why bother memorizing it? You know,
Right.
like if stuff's easy to look up, like at some point, like some of the derivatives, like I expect you to know the derivative of sine and cosine. You might say, well, they're easy to look up, but you use them so often. If you look them up every time, it's like saying to a kid, like, don't bother memorizing what 3 + 4 is, because you can always look it up on a calculator. And then the dude like can't do anything because he needs a calculator for 3 + 4. So there's like this balance point between some stuff you got to memorize. For me, Newton's method is not something like you need to memorize that because we use it all the time. Like, so I'm totally comfortable giving that formula. So Newton's method formula and also the inverse trig derivatives. Those two will be, I'll just put them on the test. That way you've got them there. You can open up the test and you can just have them there. Yeah.
Sounds good.
Yeah. Oh, the boys are inside and there's like crashing in the other room. No broken glass yet that I hear, but there's wrestling, inverse trig. Okay. And Allie, or no, not Allie, Alexis was wondering about those chapters. The ones that we are, the content that we're going to shortchange are ones that we really feel like either they're easy to kind of do next semester, like right in time, kind of refresher for that, or it's stuff that, like if you totally skip Newton's method, that was one of the topics that was recommended, but like we already covered it. And so we already covered it. It was already talked about being on the test. So we might as well just have it on the test because we already talked about it. But that's a topic, like if you did not know Newton's method at all, you're fine in Calc 2. So we're trying to choose stuff that is not crucial, which is why chapter 5, like we can't just like skip stuff because chapter 5 is super important. And you can't do Calc 2 without chapter 5, all of it. So we need to make sure we get to that. So there's some stuff in chapter 4 we're gonna like take out or shortchange that we'll make sure you're okay in Calc 2. Yeah, we'll make sure you're okay. All right, I got to end this. I have kids going crazy in the other room. So we will talk soon. We'll talk on Wednesday. We'll meet again Wednesday this week. So this week we'll do today and then Wednesday and Thursday. And then moving forward, we're just going to do Tuesday, Thursday. And I'll give you a list of videos to watch. I have up here on the screen share. I'll post this in D2L, but I'd like you to watch, for Wednesday, I'd like you to watch the 4.1 videos, and I'll link them in D2L in the news post after we're done here. But watch those 2 videos. I think there's just 2 of them for Wednesday, and then we'll do some examples. That's what we'll do, is we'll spend that Wednesday time doing examples together. Cool. All right, everybody, I hope this was helpful. You had lots of great questions. Let me know if you have additional questions, but I think that is it for this meeting. All right, now I got to figure out how to stop everything. Stop sharing my screen. Okay, that's done.